Hello, on behalf of Marissimo, Bailey, and myself, Price, we're going to explain a series circuit, a hydraulic circuit, with the associated input and output power loss in terms of horsepower. This is the schematic diagram, and we have a motor pumping with a relief valve here set at 250 psi, and I'm going to let Marissimo keep talking about how this circuit is put together here. Go ahead.
All right. This little part over here, up to this point right here, is the same as the same setup that we all have underneath our benches. All we did was set the relief valve at 200 psi, 250, my bad. From here, we test a flow meter here, and then we attach that to a hydraulic motor, a very small hydraulic motor, mind you. And then from there, we attached another gauge to measure, in order to measure the pressure drop from the motor to the outlet valve, which gave us 25 psi, and then that just leads straight back to tank.
Thanks. And Bailey, you can talk about the horsepower equation, I guess, and
Alrighty.
how that works with the load on the motor and how the power drop occurs.
We calculated horsepower by first finding the GPM, which is why the flow meter is there. We got 3 GPM out of that. Then we also needed the pressure, because horsepower is flow rate times pressure times a constant of 0.000583. So here we have 140 psi, and this is where our horsepower, the horsepower going into the motor is coming from, which is 3 GPM times 140 psi times 0.000583, which comes out to 0.245 horsepower. Secondly, we have this horsepower right here, which is 25 psi. So if we calculate here, 3 GPM times 25 times 0.000583, we come out with 0.044 horsepower.
And incidentally, why was the GPM the same here as it was over here?
Because the area did not change, and neither did the velocity.
Ah, very good. All right.
And with all that, we come out to a power drop of 0.245 minus 0.044, which equals 0.201 horsepower.
And could you figure that same power drop out by just taking the pressure drops between the before and after cumulatively?
Why, Price, you could.
Okay.
115 psi, which is the power drop right here, because we pressure drop, excuse me. 140 minus 25 comes out to 115 psi, which is the pressure drop from here to here.
Yep.
Because, mind you, flow rate does not change, and this is a constant, so it doesn't change either. We can just put this right here, 115 psi, and we'll also get the same answer here.
Can we see the circuit now? Oh,
Yes.
by the way, what was the practical application of that? How could we use
Well, you
it?
could use a hydraulic motor for tons of things. You could put it
In a conveyor belt. That's the
Conveyor.
main. That's the main point of it. That's usually why you would use a
Great.
hydraulic motor.
Well, yeah.
Okay.
You put it in a conveyor, and in this case, you would want to know the power to make sure that you have enough. Because if you don't know the power and you don't have enough, it's not going to do what you want it to do.
Right, right. Oh, very good. Well, can we go see the thing?
Sure.
Let's look.
What we're going to do is Marissimo's going to turn the circuit on and explain the series circuit here in terms of initial PSI, the GPM, and the gauges that we have on to measure flow. Go ahead, turn it on, man.
Okay, so down here we have our oil tank, the same thing that we all have. We have some modifications. What we did do, however, is set this little thing right here, the relief valve, to 150 psi. So from there, luckily for us, our motor does not take up more than 140 psi to run, so that thing's not going to trigger anytime soon. Well, once we come up from the oil tank, we can go up this hose. It goes to our flow meter right now, which is reading 3 GPM. If you want to get a shot of that, it's going to be reading at 3 GPM.
That's not going to happen.
It's at 3 GPM, trust us.
Convert liters.
We're too lazy to. And then it's running into this tiny little motor over here, which, as you can see, is spinning with decent speed and force. From what looks of it, I don't feel like testing it with my hand. And then from over here we have the output that should go back to oil. However, we have a little gauge over here that reads 25 psi, which is the part which should be the pressure drop from here to from the actual oil tank to the motor, and then it just goes back straight back to the tank.
Great. Well, you explained the circuit, and why is it important to know the horsepower that's associated with the input and output? Because of the potential load we can put on the motor. Right?
Exactly.
Because we can't overtask the motor.
Exactly.
So that's our practical exercise on behalf of myself, Price, Marissimo, and Bailey, who's taking the video.
I'm here.
Thank you very much.